Hi there. In this video, I'm going to try and fix these two PlayStation 2 controllers that I bought for 10 euros. This is the first one, and it is supposed to be the worst of the two. None of the buttons work apart from the analog sticks. As you can see, it doesn't look great. It has quite some dirt that I'll try to clean if we are able to fix it. This controller's model is SCPH-110, and this problem is quite common on this model. This problem is usually caused by the carbon pads on the Flex controller board turning bad over time. Let's see if that is actually the issue, and if we can easily replace it, starting by taking it apart. There is only one cable from one of the motors attached, so I just pull it to remove it from the board. I'll solder all of the cables when finished. We are lucky. There are different versions of this model. Ones where the flex board is permanently attached to the board, so it needs to be desoldered, and others like this one, that you can just easily unplug it. I've got a few replacements that I bought from AliExpress. I'll leave a link to the ones I got, but you can easily find them. They are not very expensive. You can check the resistance on the pads of the defective flex board. When the resistance is closer to 20k ohms than to 10k ohms, that is when problems happen. Now we can just install the replacement flex board. It has one pin less than the original, 18 instead of 19. You have to shift it once to the right, leaving the first pin, most left one, unconnected. Before moving forward with putting everything together, I wanted to test it to see if the buttons are working as expected. And great news, they do. Now, the replacement flex is a little bit wider on the R and L buttons part, so we need to trim them with scissors just a bit. We can finish up by soldering the motor cables that were snapped from the board, and put everything together. It is usually a bit difficult to install the back part when the R2 and L2 buttons are in place, so a good trick is to remove them from the case beforehand. Be careful using your good tweezers because they can bend like mine. No bueno. This is the second controller, which is in better condition. Only 1 or 2 buttons are supposed to not be working according to the seller. From this test, all the buttons seem to be responding fine with the exception of the circle button, which needs to be pressed really hard for it to respond. Same model as the other controller, SCPH-110. Even though it is the same model of controller, it is a different version, as you can see by the connection from the flex board to the controller's main board. This one is soldered in place, and thus it cannot be removed easily like the first one. Before moving forward with all the desoldering and soldering of the new connector, I wanted to try if by cleaning the contacts and the carbon part on the rubber pads the buttons would respond properly. I didn't have my hopes high though. No difference. The circle button is still not responding properly. A quick check of the resistance on the buttons. As you can see, the circle button's pad resistance is more than 20K. So, let's start with the removal of the old connector. For this, there are 2 methods we can use. One is to use hot air. The other one is to use low melt solder, which is the method I'm going to use now. We need to apply some low melt solder to all the solder points of the connector, and because this solder will stay liquid for longer, we are able to remove the connector easily. Now we can clean the pads and remove the leftover solder with some solder wick. Something bad happened here. It seems like the board bulged a bit, probably because of the high heat, and it lifted a few solder pads too. This had never happened to me before while performing this repair. But well, it is what it is. Now we have to fix this. This is not looking too good. The connector can't sit flat on the board because of the bulging, so I'm trying to break that bubble that is causing the bulge so the connector can properly sit flat and can be soldered in place. As with the other controller, this connector has 1 less pin, 18 instead of 19. So we shift it 1 pin to the right, leaving the first pin unused. It is a ground pin that does not connect to anything on the flex board. Now we can start soldering the connector. It is always good practice to touch the pins to make sure they are properly soldered. In this case, there are a couple of them that didn't get soldered. Before fixing the broken connections, I wanted to make sure that the flex board fits properly with the connector in a bit of a different position now, due to the bulging of the board. And it seems like it does fit fine. Let's move on. Now, to connect the broken pads to the connector pins, I'm going to remove a bit of the solder mask to expose the copper so I can connect a very thin wire from the trace to the pin. In this case, I'm using 0.1 millimeter enameled wire. Final checks to make sure everything is connected where it should be. Then some cleaning, and finally I apply some solder mask to protect the connections. Again, cutting the flex board to the proper size and putting everything together so I can give it a test. So it seems like things are happening. The buttons seem to be working fine, but it looks like the direction pad is constantly being pressed. Something is not right. Let's check that the connections are fine. And they seem to be all good. I'm going to put everything together more securely, soldering back the analog sticks cables and trying reseating the flex board connection in case something is not doing proper contact. Wow, it works. No more shifting of the cursor now. And all the buttons are working fine too. Great news. Time for a good clean. Very important to let everything dry before putting it back together. The first controller looks really good. And the second one also looks great. So this is it. I hope you liked the video and learned something along the way. If you have any questions, leave them in the comments down below. I always reply. Thank you.